Hello everyone, welcome to our channel Biological Concepts. In today's video, we will solve some MCQ on antibiotic. Some brief notes regarding the questions and their related options are also provided here, which will be beneficial for you. So stay tuned in this video. The first question, which of the following pair is correct? Option 1, quinolone, that is streptomycin. Option 2, macrolide antibiotic, kanamycin. Option 3, aminoglycoside antibiotic, actinomycin. Option 4, polypeptide antibiotic, polymyxin. Now, there are various classes of antibiotic based on their chemical structures. Here, 4 different classes of antibiotic is mentioned, and in another side, their examples are present, and you have to choose the correct option. Here, the correct option is option 4, that is polypeptide antibiotic is polymyxin B. Now, examples of quinolone antibiotics are nalidixic acid, pipidemic acid, ciprofloxacin, norfloxacin, ofloxacin, levofloxacin, moxifloxacin. Whereas the examples of macrolide antibiotics include azithromycin, erythromycin, and clarithromycin. Next is aminoglycoside antibiotic, and the examples include streptomycin, neomycin, amikacin, gentamicin, tobramycin. Polypeptide antibiotics include bacitracin, colistin, actinomycin, and polymyxin B. Whereas the examples of beta-lactam antibiotics include penicillin, cephalosporin, carbapenems, monobactams. Next, which of the following is correct regarding the mode of action of antibiotic? Option 1, quinolones, that is inhibit cell membrane. That is not correct option because quinolones are nucleic acid synthesis inhibitor. Option 2, rifampin, DNA iris inhibitor. This option is also incorrect because rifampin are RNA polymerase inhibitor. Option 3, vancomycin, cell wall synthesis inhibitor. This option is correct because vancomycins are cell wall synthesis inhibitor and it inhibits the second stage of cell wall synthesis in bacteria. Option 4, sulfonamide, RNA polymerase inhibitor. This option is also incorrect because sulfonamide are folate synthesis inhibitor. So the correct option is option 3, that is vancomycin, which is a cell wall synthesis inhibitor. Now the DNA guidase inhibitors are quinolones and fluoroquinolones, whereas the cell membrane inhibitor are polymyxin. The cell wall synthesis inhibitors are vancomycin and bacitracin. So this vancomycin is not only the cell wall synthesis inhibitor in prokaryotes but also the bacitracin, which also inhibit the cell wall synthesis. Next is RNA polymerase inhibitor. RNA polymerase inhibitors is rifampin. And next is folate synthesis inhibitor, and examples include sulfonamide and trimethoprim. Next question, which of the following is a bacteriostatic antibiotic? Option 1, vancomycin. Option 2, penicillin. Option 3, daptomycin. Option 4 is tetracycline. Now solving this question, we have to know what is bacteriostatic antibiotic. Bacteriostatic antibiotics are those which stalls the cellular activity of bacteria rather killing the bacteria. So this bacteriostatic antibiotic does not kill the bacteria. Okay. Here option 1 is vancomycin. This is not correct because it is bactericidal antibiotic. Now the bactericidal antibiotics are those that kill the bacteria. So this vancomycin is not bacteriostatic antibiotic. Next is penicillin. It is not a bacteriostatic antibiotic because it is also kills the bacteria. And option 3 is streptomycin. This streptomycin also kills the bacteria. So this vancomycin, penicillin, streptomycins, these 3 are bactericidal antibiotic. Last option is tetracycline. This tetracycline is a bacteriostatic antibiotic because it stalls the cellular activity of bacteria rather killing the bacteria. So the option will be option 4, that is tetracycline. Now, the bacteriostatic antibiotic stalls bacterial cellular activity without directly causing bacterial death. Examples include tetracycline, macrolide antibiotics such as azithromycin, erythromycin, clarithromycin, clindamycin, trimethoprim, linezolid, chloramphenicol, etc. And we have already discussed that bactericidal antibiotics are those that kills the bacteria. Examples include beta-lactam antibiotics such as penicillin, cephalosporin, carbapenem, amoxicillin, meropenem. Fluoroquinolone class of antibiotic, that is ciprofloxacin, levofloxacin, moxifloxacin. 3 is cyclic peptide, that is streptomycin. Glycopeptide antibiotics are vancomycin. Aminoglycoside antibiotics are gentamicin, tobramycin, amikacin. And nitronidazole class of antibiotics are metronidazoles. These all are bactericidal antibiotics. So by these examples of this bactericidal antibiotic, you also aware about the about the examples of different class of antibiotics, such as fluoroquinolone antibiotics are ciprofloxacin, levofloxacin, moxifloxacin. Cyclic peptide antibiotic example will be daptomycin. If the question comes which one is the glycopeptide antibiotic, the answer will be vancomycin, which inhibit the second stage of cell wall synthesis. And aminoglycoside antibiotic we have already discussed, gentamicin, tobramycin, amikacin. And nitronidazole class of antibiotics are metronidazoles. Okay. Next is chloramphenicol produced by option 1 Streptomyces gracious, option 2 Streptomyces aureofaciens, option 3 Streptomyces venezuelae, option 4 Penicillium notatum. And the correct answer is Streptomyces venezuelae, that is option 3. Now, Streptomyces gracious produce the streptomycin gracious S, and it is streptomycin. Next is Streptomyces aureofaciens, which produce the tetracycline. Penicillium notatum produce penicillin, that was discovered by Alexander Fleming. Penicillium griseofulvum, griseofulvin. Thus you can remember griseofulvum produce griseofulvin. And Streptomyces venezuelae L, chloramphenicol, jueli, felicol, LL. Thus you can remember. Okay. Next is, which of the following inhibit protein synthesis in eukaryotes? Option 1 streptomycin, option 2 furamycin, option 3 cyclohexamide, option 4 is chloramphenicol. And the correct answer will be option 3 cyclohexamide. Whereas the streptomycin, chloramphenicals are protein synthesis inhibitor in prokaryotes, that is in bacteria. Okay. Whereas the sputamycin inhibit the protein synthesis in both prokaryotes and in eukaryotes. Okay. So the cyclohexamide interfere with translocation step in protein synthesis, that is the movement of the tRNA molecule and mRNA molecule in relation to the ribosome. And by interfering the translocation step in protein synthesis, they block the eukaryotic translation elongation. The furamycins inhibit protein synthesis in both prokaryotes and eukaryotes. So remember that furamycins is a protein synthesis inhibitor in both prokaryotes and eukaryotes, whereas the cyclohexamides is the protein synthesis inhibitor in eukaryotes. Whereas streptomycin, neomycin, chloramphenicol, tetracycline all are protein synthesis inhibitor in prokaryotes. Okay. Next question. The antimicrobial activity of vancomycin is due to option 1 inhibition of nucleic acid synthesis, option 2 damage to the cytoplasmic membrane, option 3 inhibition of cell wall synthesis, option 4 regulation of DNA supercoiling. As we have already discussed that vancomycin inhibit the cell wall synthesis, it inhibit the second stage of cell wall synthesis. So the option will be 3, that is inhibition of cell wall synthesis. Whereas the vancomycin is a unique glycopeptide and it inhibits the second stage of cell wall synthesis in bacteria. And the fluoroquinolones inhibit the nucleic acid synthesis in prokaryotes. Polymyxin damage the cytoplasmic membrane. And quinolones and fluoroquinolones regulate the DNA supercoiling, thus inhibit the nucleic acid synthesis. Next question, which of the following is an beta lactamase inhibitor? So option 1 is galvanic acid, option 2 penicillin, option 3 beta lactam, and option 4 is carbapenem. So before answering this question, we have to know what is beta lactamase inhibitor. The beta lactamase inhibitors inhibit the beta lactamase, and these beta lactamase are the enzymes that inactivate the beta lactam ring, which is the main chemical structure of the beta lactam class of antibiotics such as penicillin, cephalosporin, carbapenem, etc. And these beta lactamase inhibitors are coordinated with the beta lactam antimicrobials to prevent antimicrobial resistance. And the answer will be the galvanic acid, option 1. That is, beta lactamase inhibitor is galvanic acid. This beta lactamase inhibitor is used in coordination with beta lactam antimicrobials to prevent the antimicrobial resistance. The bacteria develop resistance to beta lactam antibiotics such as penicillin, cephalosporin, monobactam, carbapenem by secreting beta lactamase that attack the beta lactam bond, thus inactivating the beta lactam antibiotic. Next, which of the following inhibit protein synthesis in both prokaryotes and eukaryotes? Option 1 streptomycin, option 2 pseudomycin, option 3 cyclohexamide, option 4 is chloramphenicol. We have already discussed that, and the correct answer will be option 2 pseudomycin. Pseudomycin is the inhibitor protein synthesis in both prokaryotes and eukaryotes, and it inhibit the protein synthesis by blocking the further extension of the nascent chain, that resulting in premature termination of translation. The structure is it is naturally occurring aminoglycoside antibiotic. Next question. Dash is the polypeptide antibiotic. Option 1 actinomycin, option 2 streptomycin, option 3 tetracycline, option 4 all of the above. And the correct answer is option 1 actinomycin. Actinomycin is polypeptide class of antibiotic. It contains non-protein polypeptide chain, and the examples include bacitracin, actinomycin, polymyxin, colistin. Now let's discuss the mode of action of this different polypeptide antibiotic. Actinomycin inhibit transcription. Bacitracin inhibit bacterial cell wall synthesis. Polymyxin disrupt both outer inner membrane of prokaryotes. Colistin leads to the disruption of outer membrane, that is leakage of intracellular content, and cause the bacterial death. Next is Dash is an aminoglycoside antibiotic. Option 1 actinomycin, option 2 polymyxin, option 3 gentamicin, option 4 all of the above. And the correct answer is option 3 gentamicin. Gentamicin, streptomycin, neomycin, amikacin, streptomycin, tobramycins, these are aminoglycoside antibiotic. These are potent broad-spectrum gram-negative antibacterial medication. They work by binding to bacterial ribosome, that is 16S RNA of 30S ribosomal subunit, and inhibit protein synthesis. The structure is characterized by a core structure of amino sugars, which is connected via glycosidic linkage to a dibasic aminocyclitol, which is most commonly 2-deoxystreptamine. DAS is a macrolide antibiotic. Option 1 azithromycin, option 2 polymyxin, option 3 gentamicin, option 4 all of the above. And the correct answer is option 1 azithromycin. Examples include azithromycin, erythromycin, clarithromycin. These are macrolide antibiotic. And the mode of action. Macrolide antibiotic are potent broad-spectrum gram-negative antibacterial medication. They work by binding to bacterial 50S ribosomal subunit and inhibit protein synthesis. The structure is composed of macrocyclic lactone of different ring sizes to which one or more deoxy sugar or amino sugar residues are attached. Next, which of the following pair is correct? Option 1 polymyxin that inhibit cell wall synthesis. Option 2 daptomycin inhibit protein synthesis. Option 3 rifampicin inhibit cell wall synthesis. Option 4 quinolones inhibit nucleic acid synthesis. Option 4 is quinolones inhibit nucleic acid synthesis. Polymyxin damage the cytoplasmic membrane. Daptomycin disrupting multiple aspects of bacterial cell membrane function. Fluoroquinolones and quinolones inhibition of nucleic acid synthesis in bacteria. Streptomycin, neomycin, amikacin, tetracycline, kanamycin, chloramphenicol, azithromycin, tetracycline. These are inhibitor of protein synthesis in prokaryotes. Rifampicins, it inhibits DNA-dependent RNA polymerase of bacteria. Next, which of the following antibiotic binds to 50S ribosomal subunit and inhibit protein synthesis? Sorry. Option 1 azithromycin, option 2 tetracycline, option 3 gentamicin, option 4 is streptomycin, and the correct answer is option 1 azithromycin. Streptomycin, tetracycline, gentamicin, azithromycin all are act as protein synthesis inhibitor. Tetracycline and aminoglycoside antibiotics inhibit bacterial protein synthesis by binding to 16S rRNA of 30S ribosomal subunit. Whereas the macrolide antibiotics and chloramphenicol inhibit bacterial protein synthesis by binding to 50S ribosomal subunit. So, the tetracycline and aminoglycoside class of antibiotic inhibit protein synthesis by binding to 30S ribosomal subunit, whereas the macrolide class of antibiotic and chloramphenicol inhibit bacterial protein synthesis by binding to 50S ribosomal subunit. Next, which of the following statement is incorrect regarding chloramphenicol? Option 1, it binds to 50S ribosomal subunit. This option is correct because chloramphenicol binds to 50S ribosomal subunit and inhibit protein synthesis. Next, it is isolated from Streptomyces venezuelae. It is also correct because chloramphenicol isolated from Streptomyces venezuelae. Chloramphenicol LL venezuelae. It binds to 30S ribosomal subunit. It is not correct. It is incorrect. So the answer will be option 3. That is binds to 30S ribosomal subunit. The chloramphenicol inhibit protein synthesis by binding to 50S ribosomal subunit of 70S ribosome. It prevents peptide bond formation by inhibiting the action of peptidyl transferase. Also prevents the binding of amino acyl tRNA to the peptidyl transferase active site. The structure is the molecule of chloramphenicol is composed of 3 parts. One is para-nitrobenzene moiety, second is dichloroacetyl moiety, 3 is 2-amino-propanediol moiety. Thank you. If you like this video, please like, share and subscribe to this channel. Thank you.